Okay, so my name is Bryan Piedra, and I am majoring in computer science, and I am going to be talking about the research that me and my group made for Molly.
Hey, my name's Cody. I'm a major in electrical and computer engineering.
Hi, my name is Caleb Joynorman, and I'm a forest and civil engineering major.
Hi, my name is Doneker. I'm from Portland, Oregon, and I'm doing general engineering.
Hi, my name is Josh Stewart, and my major is forestry/civil engineering.
So our group's problem statement was to improve the lifestyles of Mali citizens with a moderate level of funding by creating safe and efficient solutions with regards to some of the many problems that they face. So that was kind of what our basis of solutions was. We wanted to, find common problems that, a lot of Mali citizens face. And some of these were access to clean drinking water, health improvements for common diseases such as malaria, a source of thermal energy for cooking and heat that's safe and efficient, an efficient, safe, and easy to use source of electrical energy for community growth and expansion, and finally, a reliable and safe form of transportation.
So as a team, our proposal and objective for this project here in a small village in Mali, we had to come up with a efficient, simple, and safe way to bring modern technology into this village. And our best option that we could come up with for clean water was the H2Go. It's simple and easy to use. Just about anyone can use it. And what it does is it adds chemicals into a large quantity of water to purify it, kills all the bacteria, so it's good drinking water. And the benefits is it doesn't intrude in surrounding areas, so like land and then other bodies of water. It doesn't kill other species of animals, and then it lasts up to 124,000 liters, or right around 33,000 gallons. The only risks are that the device ends up breaking or just runs out of charge, or like other villages might even try to steal it, or other families try to steal it to have clean water. And then the cost is only right around $100 per device. And then the engineers that came up with this are mechanical and environmental. And then for the SDGs that were covered, there was the good health and well-being, clean water and sanitation, responsible consumption and production, and then life below water, and then obviously life on land.
For the electrical energy portion of this, we wanted to supply the village in Mali with clean, reliable electricity. We found the best way to do this was with the SunGold Power solar power inverter. It uses solar energy and converts it into usable power for large-scale applications, such as a village or multiple small houses. It costs $3,950 per unit. It can put out 120 or 240 volts, depending on the way it's configured. It uses clean, sustainable solar energy, which is plentiful in Mali. One of the risks is that it might be susceptible to harsh weather, such as sandy conditions, or just all-around dry conditions that could dry out the wires. It is somewhat dangerous to operate and work on due to the high voltage. Some engineers that would be needed to manufacture this would be an electrical engineer and a mechanical engineer.
We chose the RDT test because it seems like the most effective way to help with the malaria problem in Mali. It would be too difficult to prevent people from getting the disease, so allowing for them to get rapid testing would effectively help the population. This would allow them to seek proper treatment. So the benefits for this are, it's a low cost of approximately $40 per test when one buys a pack of 12 for $470. They have a long shelf life, which allows them to be used when needed. They are small, light, and easily portable. The RDT test typically produces results in about 20 minutes, and it's very easy to use. Some risks are, when using disease tests like this, there's always a chance that you can get a false positive or negative, which can lead to some problems. The RDT tests tend to expire a little faster in warmer climates. A blood sample is required, which detects these malaria antigens in a person's blood, which can be difficult for someone with hemophobia. The tests are single use, which can create some waste. This solution would require a biomedical engineer. This covers number 3 of the SDGs, which provides the people with good health and well-being. The estimated cost is around $80 per person, which would allow them for 2 tests per year. We are confident that we chose the right decision.
For our habitat solution, we chose a storage container house as it met many of our goals for solutions. Since the container itself is made out of recycled materials, it is quite inexpensive to build and personalize. There are thousands of shipping containers already in surplus, so this is a pretty eco-friendly solution. And it is quite durable. This meets another one of our solution goals for the project, which is future sustainability. So the cost for the base model of the storage container house is $25,000. Some benefits is that the solution is quite inexpensive since it's made from recycled materials. It allows for expansions, and storage containers are quite easy to ship. So this is a very good solution for mallee habitats, especially in areas that aren't very accessible and are far away. Some risks is that this might not offer enough space for if it was occupied by a large family, for instance, 10 or more people maybe. So expansion may be required, which is more expensive. Another risk is that the solution might not be environmentally friendly depending on the region that it's in. Might involve the process of cutting down trees in order to build homes, or maybe other forms of terrain deformation. An ecological engineer would be involved with the creation of the solution, since the house needs to be implemented in a variety of different environments. This is to make sure that there is little to no impact on the surroundings of the habitat. And this solution meets 3 sustainable design goals, which are sustainable cities and communities, life on land, and reduced inequalities.
Okay, so for our thermal energy, we decided that we were going to use an eco rocket stove. As there's an image on the right, we can see, and the cost for this would be $395. Some of the benefits that we saw from this stove were that we don't have to use as much wood to get heat in from the stove or to cook food from it. It also has a reduction in smoke compared to other traditional stoves that we're so used to seeing. Some of the risks are that you could potentially get hurt getting burned by it, and also depending on where you're living, the coal could be expensive. Some of the engineering that we might need would be manufacturing engineering, and this would be just to make sure the stove is in good conditions at all time and that it's safe. Some of the sustainability design goals that we went through in this design was zero hunger, responsible consumption and production, and sustainable cities and communities. And then for our transportation, we got the Sun Cycles Delivery e-bike. As we can see, this one's $1,679. Some of the benefits is that you could ride around with it and carry stuff with you, like we can see on the image on the right, the man carrying a suitcase and a box in the back. And it also gets you from point A to point B at a faster rate than, for example, walking. Some of the risks could be that someone might try to steal it, or you could potentially get hurt if you're not riding it correctly. We would need an electrical engineer to make sure the wiring and everything on the bike is correct, especially since it runs through solar power and it's also electrically plugged in. Some of the sustainability design goals that we saw with this one is that it allows the person to move effectively, which could be a good thing, both infrastructurally, innovationally, and industrially, because this helps a person move and potentially trade with other people around nearby them. And then finally, we got the estimated cost per person per year. So what I did is added all the numbers together, and we based it off of a family of 5 because, for example, it wouldn't make sense to say that one person, it costs like 2,500 for the storage container when it can contain more people. So we came to the conclusion that it costs around $31,000 per family per year. This is assuming that they each take around 2 malaria tests a year. So what I did was just divide this number by 5, and that's when I got $6,304 with 80 cents per person to be living under this program.
So some things that we weren't able to answer or come up with solutions with were during major drought, the village would face some difficulties that the water purifier would be unable to help with. We can only purify their water and not grant them access to it. We can't just give them water. That would be too difficult and probably too expensive. We are unable to control or help with the social implications of these new products. Maybe some people would be unwilling to try these solutions. We simply don't know.
So to reflect, our main focuses for choosing these solutions were primarily based on 2 factors, which were safety and reliability. And for the most part, these goals were achieved. A sub-focus we did have was to find cost-effective solutions, which, while it was a priority, it wasn't the ultimate goal. We wanted, all our solutions to be safe and reliable rather than, even if it is extremely expensive. Further topics that our group wanted to explore that were involved within the scope of this project include education, food/hunger, and medicine. These are key when we're talking about future sustainability and expansion. since if we want to do that, we need to educate the future workforce and have a sustainable source of food for everyone and easily accessible medicine. So those are some key things to keep in mind. In our solutions, our general confidence was high. We did have one outlier though, which was storage container solution, which is quite expensive for citizens. While its manufacturing cost is pretty inexpensive, but it's $25,000. That can be hard to come by, especially when it comes to expanding, which is something to keep in mind for future sustainability. Some key areas though to focus on for future sustainability: electrical, energy, habitat, and clean water are all areas that we need to focus on. If the village has sufficient energy needs, large enough habitats, if there's is there enough clean water for everyone so no one goes thirsty, and health is another key area to focus on, as more and more health problems might need to be dealt with as the village expands. So maybe the introduction of new diseases, and what are some cost-effective solutions that can provide for that. All right, so that was our presentation on Mali, and I hope you guys learned something. If you have any questions, Q&A now, and yeah.